We are a subcontractor downstream. We are completely different than a lot of the larger firms you see utilizing software like this. And I think it's going to give good contrast to see someone like myself that's actually involved with the building process. We're not managers, we are actually builders. So for us, a little bit different application in terms of how we do it, but nonetheless very important, I think, to see downstream how a company like us actually takes advantage of Tekla. So first, a little bit about yourselves. We're located in Lombard, Illinois. It's a west suburb of Chicago. Here's a beautiful Chicago skyline. A lot of the work we do by nature is very tall. We have a lot of high-rise, multi-story residential type work, a lot of hotels. Most of the work we see is anywhere between 30 and 60 stories, so quite large structures. We've been in business a long time. Since 1930, we've been around. Up until 1988, we were actually strictly a formwork contractor. I understand locally that still goes on to some degree, that they break out the different packages, whether it's forming, whether it's placing and finishing, rebar setting. That no longer is the case locally, at least for us. It's not packaged under what's called like a concrete frame package. So you have specialty contractors doing some of the deep foundations, and then a company like us would take it basically from the top of the foundation up to the roof level. So all formwork, all rebar placing, finishing, setting, post-tensioning is very big in our world. It's all under our contract. We're typically in the top 20 by revenue. We don't really pay too much attention to those kind of figures. For us, we do a lot of jobs that are quite large. We could do a $15 to $30 million job. So the difference between getting 3 and 4 jobs in any one year drastically affects the volume of our work. But I would kind of categorize Adjustable Forms as a small company that does large and complex structures. First off, I just want to show a few typical projects. Here's just a few screenshots of jobs we've done in the recent past and a few that are actually going on right now. It just gives you a feel of the type of work we're performing. Like I said, a lot of large scale. Any one of these you see is anywhere from 30 to 60 stories. All actually are post-tension reinforced concrete frames. It's actually a bit of a building boom going on right now in Chicago, which has been quite a blessing. The last 5 years or so have been pretty brutal, I think, globally. Outside of what seems to be ongoing construction locally in London. I was amazed how many cranes are actually up in the site or in the city. In Chicago, there seems to be a resurgent. A lot of rental units seem to be built right now. So, fortunately for us, we've been kind of riding that wave, and work has picked up steadily in the last couple of years. So, just an overview of what I'm going to discuss. We utilize it as an in situ concrete contractor. I still have to get used to calling it in situ. If I say cast in place, interchangeable. I'm going to talk a little bit about why Tekla is a preferred software for a company like us. We're downstream. We're a subcontractor performing the work. So for us, it's a little bit different. We're not the designer. We are not involved with ownership. We're down, actually swinging hammers, performing the work. We're physically tied to the building of the structure. I'm going to talk a little bit about the benefits of why Tekla was our preferred software. You all probably have heard of all the different packages out there. You know all the names. You know what they do and what they don't do. I'll show you a little bit about what Tekla really can push for a company like us. How we actually utilize Tekla might be a little bit unique from what you see from other applications. We heavily focus actually on the pre-construction side. Prior to getting the work, we're utilizing the modeling tools in Tekla. That's a little bit different than you'd see at most contractors, especially ones of our size. Moving on to the construction phase, we hopefully get to take that workflow and seamlessly transfer it into what we're actually using in the field. And then finally, on the project turnover, turning over documents to ownership, as-built information. Tekla allows us some tools that you typically wouldn't see for a contractor like ourselves. And finally, I'd like to talk about how we can actually justify the software. I know there's quite a few cast-in-place in situ concrete contractors in the room, and a lot of you are probably similar size to us, I would imagine, maybe a little bit bigger. And it's quite an investment to do new software, to handle the resources involved in training, and we get that. We're a contractor that has probably a smaller office than most, given our size. So making that business decision to actually use something like this is a big one. It's important, and it's important that you get it right. And finally, I'm going to talk a little bit about some of the case studies of recent work. The 4 jobs I'm going to kind of highlight in general. One of them we're actually bidding, 2 are under construction, and then one is the one we did about 2 years ago. If you have any questions throughout the presentation, by all means. So first off, why Adjustable Forms utilizes Tekla? For me, it was about finding the absolute best product for what we do. So we are a concrete contractor. We know exactly what we want to do. We don't want to be a precast guy. We don't want to be a structural steel guy. We don't want to do drywall. We're pouring concrete. So using a tool like Tekla just made sense to us. It's the one tool that's out there that's specifically geared to someone like myself. We always talk about designer's BIM versus the construction-minded, detail and data-driven BIM. That's really what drives the show. It's not how great the model looks. It's what kind of information you can pull out of it. So you have inputs and you have exports out of that model. What are you using it for? Tekla, as we had mentioned earlier, been around forever for structural steel, moved into precast, and now the natural progression is obviously cast in place. We've been using it 4 or 5 years, and each year that we've used it, we've seen increases in terms of what we can do, new tools that have come out. It's really exciting to be a part of something like this because it's, as you all know, a slow-moving industry. Change is so painstakingly slow that it's nice to see something like this kind of shake up our industry. I think the I in BIM needs to be remembered a little bit more. We are talking about information here. Ultimately, 3D modeling has always existed in some form. The information data loading is what's kind of new and exciting about this. It's that you can actually take real data and use it for your benefit. We call it the Hollywood BIM, or the fluff BIM in the States, but basically it's painting a pretty picture, making something look good, but at the end of the day, did you actually affect the construction process? And a lot of times the answer is no. And we see it all the time with large global companies working in Chicago. They're just not using BIM as it truly should be intended. It's quasi-marketing tools is what I would say. And I'm hoping that they start to see the benefits of working with contractors like ourselves. I think we're getting better and closer, but it's hit or miss at times. As far as the usability, if any of you have tried some of the competing products, you know that they can be clunky and slow, and once you start building them up, they slow down substantially. With Tekla, you really don't have that issue. Even with a modest workstation, we find that it's very fluid modeling, very fast. It's been an absolute blessing to have something like Tekla where you don't have to spend 10 grand on a workstation for each of your BIM guys, that you can use just a modest workstation and it works fine. They did not pay me to say that that really is the case. I'm truly amazed because I was skeptical after using some of the, I'm not going to mention them by name, but the competing products, they just don't have that. The customizable aspect, Tekla truly can be kind of morphed into however you want it to be. If you want to use a certain tool in Tekla, you can. There's usually a different way to do it. Whether right or wrong, you have the options. You're not locked into a certain way of doing things. And I think that's important because we're all different. We all probably have some involvement with reinforced concrete, whether you're designing it, whether you're a general contractor managing it, or if you're actually pouring. But at the end of the day, how we do our work, it is more or less the same. So using a tool like this, if it works for us, I definitely see potential for a lot of you. There's an open API, and there's also these, the extranet they call it, which is a website that I'd almost compare it to like an Apple store or like a Google Play store. There are these add-ons that you can put in the software, and they're constantly being updated. It's fantastic what they're coming up with. And finally, they did not pay me to say this as well, but they are really great people at Tekla. I have personal relationships with a lot of the people in the States, and it's really refreshing for a software company to be able to have that relationship with the customer where they actually ask me for feedback, I'll give it to them, and subsequent releases of the product actually have feedback that I was suggesting. You generally don't find that specifically for cast-in-place type applications with a lot of other software. So I can't say enough of good things. So how do we actually use Tekla Structures? On the pre-construction side, we do quantity takeoff and extraction. That's all model-based. We do drawing coordination, and we actually identify issues prior to stepping on site. We actually, in many cases, are giving these issues to the general contractor and to the owner and design teams ahead of even having the job. Now, a lot of our work is private, and it's competitively bid, so we owe the plans and specs. So there's really no incentive for any other contractor to be doing this kind of coordination on the front end, because there's really, until you contractually have the job, there's no real benefit. But our clients are seeing it differently. They're starting to understand that if you can find some of these issues in the drawings on the front end and work together to fix them, when you step on site, things get a lot smoother. Instead of 500 RFIs, you maybe have 50. So Pre-construction has been a big deal for us, really nice for communication as well. Now when we get to the construction side, if we're fortunate enough to get the job, and like I mentioned, most of it is hard bid. It's pretty competitive right now in Chicago. Margins are still, despite the uptick in work, margins are still very much constrained. But if we do get the work, a lot of what we've done already on the pre-construction side can be transferred into the construction phase. And that's a beautiful thing. You've done so much work on the estimating side, developing quantities, taking off concrete, formwork, rebar. Why would you use a product where you can't take that and then use it for something else? A lot of the 2D estimating systems, for example, once you've extracted a number that you submit that bid, it's dead. There's no real information transfer. So the process of going through layout and developing pours and detailing and shop drawings, it's all kind of separate process. So with Tekla, we're combining everything together into one model, one environment. We're getting in a lot of rebar detailing, schedule loading, the fourth dimension, deliveries, rebar deliveries. We're starting to use that to schedule the deliveries. Shoring layout and drawings. We own all our shoring equipment. It's a big competitive advantage for us locally, and to be able to actually model the shoring components, do a quantity extraction, and we can do piece counts. We can say exactly how many shoring frames we need at this dimension. Our trucker can get a report, and he sends it right to the field. It's a seamless process. Safety systems as well. That's something we've been modeling more and more. The general contractors, at least in the States, have been very adamant about pushing safety. Quite honestly, I can't believe how much better the safety is in this country. I mean, I've been looking at a few job sites locally. It's unreal. My hat's off to you for how clean of a job site, and it looks very, very nice. Finally, on the project turnover side, typically as-builds are given in 2D PDF shop drawings. Very basic, very annoying to an owner. If they need to look through something, they need to figure out, can a penetration exist in this location on the floor? Well, they're thumbing through PDFs or physical drawings in some cases. Well, with Tekla, and what we're doing is now we're turning over a model complete with all the reinforcement, all the concrete, we're data loading it with the actual mix designs. So what they're getting is a true as-built model that has data built into it. Not every owner is savvy enough to understand that benefit, but I think we're close to getting, on the private side at least, a better understanding. So leveraging BIM as a specialty contractor, an in-situ contractor, quite frankly, we cannot control the process upstream. We're small, relatively speaking, and to justify it takes quite a bit. It's a lot of time, it's a lot of money. We're not required by contract. In this private work in our world, nobody's telling us, hey, Eric, you need to use BIM, you have to use Tekla, you have to use Revit. None of that. We don't have that. So we're also not formally required for anything on the GC side in terms of, after we get the job. They say, oh, that's great, you're a BIM contractor, but they don't outright tell you in their contract that you're required. We also have competitors that are, fairly unsophisticated. They might be driving their pickup truck to the job site, and that's their operations. They don't have a lot of sophisticated stuff that we're trying to implement. So it's very tough when you think about it in this fashion. How do you justify this? And the answer to that is that you have to integrate it into as many of your operations as you can. We can only utilize this tool if it's faster, if it's more efficient, and if it's more accurate. The whole modeling for the sake of modeling just drives me absolutely nuts. A lot of people say, oh, we're a BIM contractor. And I look at them and wonder, well, what does that mean? I mean, are you using BIM to show things? Are you just showing it to visualize? Are you using the information out of it? Maybe you're just doing clash detection. But it's so much more. There's so much you can do. It involves a collaborative approach. I mean, it really does. And it's difficult, but you have to start somewhere, and starting small is definitely the way to do it. So pre-construction, the first phase prior to us getting the job. On the left, you can see what, I don't know if anyone's familiar with on-screen takeoff. It's a very popular two-dimensional takeoff thing. It's more or less a PDF overlay type thing. It's a coloring book, more or less. You're drawing on a piece of paper to scale, and you get quantities out of it. We're pretty much done with that. What we're doing is, you can see in the bottom right, so we're taking 2D design files. Some of the engineers and architects are not in the 3D world, and that's okay. We're creating a model with Tekla, and finally we're extracting quantities. So if we have design files, fantastic. If we have a model, even better. Maybe we have none of the above. They give us PDFs because we're just bidding, and they're not comfortable giving a subcontractor design files. That's okay. We can find a workflow that'll work. When I say that the designer cheat, what I mean by that is you got to be very careful with these models coming from architects and engineers. You know, we find very often, more often than not actually, that the model might not be indicative of what's actually showing up on the drawings. And obviously, if you see a beam on a plan view, you know, on a PDF shop drawing, or on a structural drawing, I should say, and then you look at the model and that beam's not there, they cheated. They annotated a 2D drawing. So there's some contractors think that, oh, if I can just get the model, I'm going to run a tool, extract all the quantities, and I'm golden. And my estimating budget is cut in half. And we're a little bit tentative about that workflow. So in any case, we actually do recreate the model in a Tekla environment. And that allows us to coordinate the drawings to make sure the scope is correct. You know, upon extracting the quantities, we import it into an estimating tool, and then we can price it. And the beauty of Tekla is that you can export it in any way. You know, maybe you use Excel, maybe you use a specific type of estimating software. It really doesn't matter. You can use it pretty much however you need it. One of the benefits that we found actually is that it minimizes the impact of an unfit competition. You know, we do, like I mentioned, have some unsophisticated competitors. And I can't control how they take off their work and how they bid, and I never will. But by allowing the model to be shared prior to getting the job, inevitably what happens is that model gets shared with my competitor. Right or wrong, it's going to make its way to his office. And when it does, they're going to look at it and say, oh my, I didn't realize that there were walls on the roof. I didn't know there were curves all over at the ground level retail. I didn't know there was columns there. We're actually, in a way, kind of minimizing the impact of people that are not spending the time and giving it due diligence. And it's unbelievable when it happened. I mean, the light just went on. It's like there's actually upward pressure on our competitors' prices because the raw quantities are increasing. They're not seeing some of these things on the front end. We're showing them to the world, and you know they're making adjustments. So kind of an unintended consequence. So the first job I want to talk about is actually a job we're bidding right now. It's called 1K Fulton. It's actually with a local office of Google and SRAM, which is a bicycle component manufacturer in Chicago. They're moving in there within the next year and a half, 2 years. The main contractor is Lynn Mathis. They're a small general contractor, not particularly BIM savvy contractor. It's actually an old 100-year-old cold storage facility on Chicago's west side. There's a lot of work to the existing facility, and the existing facility would be the larger structure here, and then the new 7 stories here with the green roof right in the foreground. So roughly a 200,000 square foot new concrete frame. This is a little bit different than what we typically chase. Typically, it's a lot taller. You know, some of the high-rise stuff you see in the background of this picture. So here we're looking at the existing structure. It's demoed down, the facade has been taken down. There's actually 4-foot thick ice on each floor that they had to thaw out. And despite the fact that it's 95 degrees and humid in Chicago, I've been told it took like 2 months, and there was just a waterfall of ice and water dripping down. So I didn't get a chance to see that. But so here we actually have a laser scan. I thought it was very appropriate to hear about some of the scanning capabilities in the industry. Well, here's a practical application of how a smaller company, a little less sophisticated company, is using that data. So we took a point cloud as a 3D DWG. We imported it into Tekla Structures, and you can see in gray. And here's just another view of that same structure. So the general contractor provided this to the subcontractors. We were very happy to see that they're sharing the design information. It's very important to be collaborative. And what we did is you can see the workflows. We built a model with that data, the existing data, exactly as it is. Now, we didn't just look at a drawing. We looked at both the drawings and the as-built information. So what we did is we developed a scope that we absolutely know is correct. You know, the quantity risk that we take on a job like this is very low. You know, you all know that if you're doing topping slabs on an existing structure, I mean, there's substantial risk in those quantities. Do you think that a 100-year-old slab is going to be perfectly level? Of course not. It's going to deflect. There's going to be irregularities. So maybe that 2-inch slab actually is more like 3 inches. So, you know, taking off quantities and extracting out of the model in this fashion, it makes perfect sense. The top screenshot you're looking at here I thought was pretty cool to see. This is actually a stair/ramp detail. It was shown on the landscape drawings, but ironically not the structurals. And in 2D, this would have been a nightmare. Anybody that's taken off stairs in concrete in general knows that stairs are awful. But in 3D, this was a half-hour work. Now, this is actually a topping slab over rigid insulation. The rigid insulation is tapered from 0 up to about 3'6". So doing it in Tekla, I know absolutely clear how much rigid insulation, how much form area, how much finish area, and how much concrete. Very slick way to do something that's relatively complex. You know, if you look down below in pink, you'll see little extensions off of the foundation wall. And what that is actually accommodations for the sheet piling. You know, we have a one-sided form condition. We're pouring into sheet piling that's going to remain in place. Now, typically what a concrete guy like myself would do was apply a waste. They would say, oh, that's probably 10% waste. But why? I mean, why would you just assume that? When in a tool like Tekla, you can actually model it specifically to the section and get exact quantities. We actually showed this to the contractor, and they just smiled and were blown away that we actually even thought of doing that. Like, this is so cool. And we're like, well, it's not just cool, it's something that helps us. You know, we minimize the risk of blowing an estimate based on quantities. Down below, you can see that they actually have like a 45-degree beam truss detail. It's actually, the column is not supported by footing on the right. It extends only to level 2. So again, in 3D, that detail is very easy to do. You can see on the right in yellow, over the gray structure, all the topping slabs taken over the 3D laser scan. Very accurate. We feel absolutely 100% good about our quantities. You know, whether or not somebody comes in and undercuts us, we can't control that. But at least we know that if we're fortunate enough to get this work, you know, we have less risk than the next guy. Another cool thing about this is actually in the bidding stage, they released an addendum. So the drawings change, as they always do, and they continue to change. And lately it seems like they change just non-stop for us. And it can be very frustrating to try to communicate the changes. So what we've been doing now is using what's called UDAs, user-defined attributes. And in here, in this case, we had scope reduction and some additions. So the roof level topping slab was removed. So in the red, you can see there's a red object at the top of the building. There's also a mechanical curve that they told us was going away. It was getting redesigned. So boom, we deleted those two objects. And they told us that there's going to be additional slab on grade. So you can see down at the bottom in blue that there was added slab on grade. So when they asked us, you know, a follow-up interview, hey, adjustable forms, do you have all these things? We sent this to them and said, absolutely. And they smiled and said, we believe you. You know, we know exactly that your scope rocks out on a job that's a little gray. You know, existing work with new work, intertwining the two. It can be new, brand new, you know, multi-story high-rise type stuff where it's pretty cut and dry in your quantities. So, as I mentioned earlier, it's kind of a scope equalizer among competition. So moving into the construction phase, you know, I talked a lot about how we took a model prior to winning the bid. Now we're moving into where if we actually have the work, we're fortunate enough to have gotten the job. We take the model that we've already created. We've already done the work. You know, the idea that you have an estimator and you have a project manager and you have the BIM guys, that needs to break down. I mean, you're looking at the BIM department in our company. You know, I do a little bit of that. I do mostly on the project management side. But it's important to note that the traditional, like, you have to go this route or this route needs to kind of break away for this to work. You know, it's just as important for a project manager to know this as it is for an estimator. And it can be done. You know, it's very easy software to pick up. So with Rebar, you know, the next step, we model all our jobs with 3D Rebar. And when I say we typically would have a detailer / fabricator. In the States, that's typically how most would do it. There's 3 major companies, CNC, Gerdau, and Nucor. Those are the big 3. They've kind of consolidated a lot of the industry in the States, at least, and bought a lot of the small shops. So they're actually taking the detailing as well as fabrication. And it's been a benefit to us because of these big companies. They're sharing the resources invested in Tekla. So I think personally we're kind of past the tipping point where we're seeing more and more embrace the software. It's always Tekla. They always investigate, just as we did, a lot of the different products. There's a lot of competing products. There's even more so, I think, on the Rebar detailing side. And they all end up going back to Tekla. You know, there's been a lot of failed attempts at different software, and I feel bad for them, but you know, you can only say "I told you so" so many times. You know, multiple jobs. We've probably done 5 or 6 jobs now with Tekla Rebar, 3D Rebar. It's important to note that you're modeling the rebar, and then you're producing shop drawings. You know, at the bottom left, you can see that that's a traditional 2D shop drawing. I know it's small, but and then on the right, highlighted in red, that's a bend list. There's no difference in terms of what the end product is. It's just how it was created. And the benefit is if the iron worker says, "I don't understand," you know, show me that detail. You bring them to a tool like BIM Site, the free viewer, and you can show them in 3D exactly how that's to be installed. You can find errors, you can find issues with congestion zones. It just makes sense. I mean, Tekla is fluid and fast enough and works so well with Rebar that, you know, it's everything that some of the design tools are not. It's not clunky, it just works. That's the best way I can describe it. You know, the efficiencies. A lot of the Rebar detailers tell me now, and this is probably 2 to 3 years of using the product, that they model faster in Tekla than they ever did in some of the other softwares, you know, the ASAs of the world, the Rebar detailing softwares. They say that it's a faster product for them. So, I mean, you know, right away, this is guys, you know, at first, they were a little bit hesitant, as you know, anybody is in construction. But, you know, as you get comfortable with the product, you find that there are definitely efficiencies, and it just works. Second job I want to show is Northwestern University. It's North Campus Garage. It's just north of the city in Evanston. Lindquist is the contractor on this. We do a ton of work for Lindquist locally. It's a 7-story. Actually going to add 2 additional floors at some point soon. It's been a mess, to be quite honest. I never realized that a parking garage could be changed so many times, but believe me when I say they can. It's been terribly frustrating. We've gone through 37, since I left, 37 drawing revisions, and we're at level 2 on the job. So 37 times there's been substantial revisions. You all know the headache that causes. You know, we're at 275 RFIs, and a lot of them are quite major. Perfect opportunity for BIM and for Tekla to get involved. So we're happy to be in it. Here we actually show Tekla BIM Site, free viewer. It's a great tool. I showed this just because I want people to realize that whether you're savvy with technology, whether you embrace the 3D world, or whether you're just kind of a high-level guy, a viewer like this, it's accessible to anybody. I mean, whether it's BIM Site or something else, you know, even 3D PDFs are really taking off in our world. Anybody can look at this 3D world and help themselves out. So, you know, even if BIM is not, you know, actually being a hardcore BIM guy, a Tekla guy, is not for you, there's ways to take advantage of what we're doing here. Here's the middle row of grade beams and the pile caps of the job. You can see some slab on grade steel as well. Here's one of the caps. I would say it's probably the most heavily congested cap on any parking garage at this height we've ever seen, but that seems to be the trend on this job. A very conservative design. Here's some of the wall steel. You can see the trim bars. I've left out some of the concrete just to get a little bit of clarity because there's a lot going on. But here you see typical 2D shop drawing. You know, nothing revolutionary. This is exactly as you would see it previously. The difference is that you have a nice, clean model to work with to coincide. Now, another job at Northwestern University as well, a little bit smaller of a job, a little bit smaller than we typically do. It's with Preconstruction, another local GC. It's just 6 stories infill, so 3 sides. It's actually surrounded by an existing tech building. It's a joist slab. We call it pan forming in the States. I'm assuming that's probably similar over here. But here you can see the progression of the model, the foundation on the top left, and as you proceed up the structure. We phase everything exactly as we build it. When you see design models, you'll often see the designers run a column up 6 stories, 7 stories, 30 stories at times. And we all know that you don't build a column 30 stories at a time in the cast-in-place world. So even if you get design models, you have to keep in mind that you also need to think about how you're going to build this. And that's important in Tekla, because that's what it is. It's a contractor's tool. It's a designer, a detailer's tool. Here you can see a visualization setting that we actually modeled. It's called color by phase. So you can see it broken out. Each individual phase represents another level on the building. And if my superintendent says, Eric, I need what the quantity is at the level 2 slab, I'll be able to tell him exactly what it is. There's absolute clarity, no doubt about it. It's exactly what he needs. And in the past, this would be our tech engineer, our surveyor on site. He would be handling this, and he would do it by hand. And that's just so backwards to me that we've spent all this time on the front end. We need to push that data downstream to our field guys. So again, the field guys can be tech savvy or not tech savvy. It doesn't matter. You just need to work together. The final case study that I want to talk about is Clark and Grand Hotels. This we did about a year and a half ago now. It's actually 3 hotels in one structure, one L-shaped floor plate split in half with a pour strip. We phased it actually, ran it north and south, so concurrently building the north and south phase. It was a 6-month job. We typically do 3-day pour cycles. In Chicago, it's usually 3 or 4 days for every floor. Here's a screenshot showing some of the foundation mat and grade beams. Like I said earlier, we take everything above the caissons. It just so happened the fabricator doing the rebar on this job was also doing that package. And here you can see again, it's a traditional 2D shop drawing. So if your field says, and I know how iron workers can be, you know, I don't want to embrace BIM, that's fine. But don't let that hold you back. They can still get their 2D placing drawing. And maybe it's that they supplement it with a couple screenshots of the model. You know, you can do that. Maybe there's complex geometry that you need a 3D screenshot, and you can set that up. And again, highlighted in red is the bar list. You know, ultimately, it has to tie to fabrication. You know, if Tekla couldn't do that effectively, there would be no reason for them. They'd be modeling to model. You need to have it in your workflow. And now I say no iPad for the iron workers. I'm joking, but I'm kind of not. Yeah, everybody seems to be pushing the tablets. I don't know how your iron workers are, but in the States, it's not happening anytime soon. They are probably the least likely to embrace a lot of this technology. I wish that would change, but I am a realist and a builder, so you know, maybe yours are different. I hope they are. The shoring modeling. So we own our shoring equipment, and we try to detail it internally. And what you see here is a floor of shoring. We have the decking materials. We have our joists and our stringers. And what we do is we actually produce the 2D shop drawings out of this. We extract quantities, so we'll have parts lists, and we can send this to our yard manager. We can send exactly what we need to that job site and nothing more. In the past, it was our field, you know, hey, send me 2 truckloads. Well, what does that mean? And once you visit the job site, you would see that, you know, a pile of shoring frame sitting in the mud. And it just kills us. I mean, we're begging for material on one side, and we have it sitting in the mud on another. So we're hoping by getting better in this facet, it will certainly help us out in that regard. Crane logistics. I'm just going to briefly talk on this, but in 3D, showing the swing radii, it's fantastic. You can identify locations very nicely. A lot of contractors have taken it to the extreme where they're actually importing, you know, specific crane models. There's doing a whole lot in terms of pick loads and as far as capacities. We haven't taken it that far, quite honestly, but it's kind of on our radar. Safety systems. We're actually at the point where we're modeling a lot of our safety systems. And the reason we do that is for site-specific safety plans. You know, as a subcontractor, to communicate exactly how it's going to look on a floor is very valuable. You know, for us, we do it a little bit differently. For our permanent fall protection on the perimeter of high-rise work, we have like a cable and netting, where you actually have just steel cable. You drill an epoxy like an eye bolt into a column or a wall, and you actually secure like a transparent blue mesh to that wire. That's typically how it's done with us, so you can see that model. You can also see little yellow straps out of the columns. Those are cast-in straps, safety straps. So we're required to provide one for the window trades, so when they're out on the perimeter of the job, they're all there and protected. They have a place that they can safely tie off. So again, we model them, show exactly where they're at, we extract the quantities. Here's just a couple other screenshots of that same system. So in conclusion, you know, embracing Tekla or any product to better your business is important. You know, I don't think people need to look at BIM as something you just have to do because someone else is doing it or because it's the buzzword of the industry and everyone's talking about it. You have to have a reason. You want to get better at doing something. You know, maybe you pour concrete directly and you are fed up with your field screwing up embeds. Maybe you need better layout tools. You know, maybe your quantities are all off. Have a specific need and then expand that as you develop, you know, your operations, your workflow. It's not just marketing software. You know, I mean, I'll be the first to admit Tekla does not take beautiful screenshots like some of the competing products, but that's not what it's designed to do. It's detail driven. You know, it's the data you're putting in and getting out. You can do flashy stuff with the marketing and all the cool videos and stuff, and any other, you know, there's a million third-party type apps and stuff. That's not what Tekla's about. You know, where to start. It's important to get the right people involved in the decision. You know, I've seen a lot of companies that have been held back because very high-level people in the organization aren't really on the ground level in terms of how things are actually working. You know, maybe they don't truly understand the workflow that's going on. So it's important that you have people that are actually doing the work. Get the estimator involved. Talk to him about what his problems are with takeoff. You know, get the engineer, the tech engineer on site, and tell him, you know, ask him about layout. You know, what are his struggles? How does he do his layout? I mean, is he doing the same tasks that you're already doing a model? I mean, if so, there's efficiencies right there. And we talked about how you can justify it when you're a company like us. Well, that's a perfect example.